Okay, finite math students, hi there. Let's work on two problems in this video. I don't want this video to become excessively long, so let's limit the video to just two problems from your first homework assignment. We're going to work on problem number 77, and we're going to work on problem number 78. 77 and 78 are very similar. Okay, they're very similar problems, okay? So we have problem 77 and problem 78. Those are the two problems that we're going to tackle in this video. Okay, so I have my my Pearson homework assignment is in front of me. I have Mathematica opened. So I have two windows opened. Let's see, format. Excuse me. Edit style sheet. Input. Excuse me. Input. Output. And just in case we need it, text. Okay, so let's see, format. I don't know, how about 20? You know, it depends on the computer that you're using. It's going to be a little bit different, you know, on every computer. So I'm going to say Ubuntu Mono. I'm using an Ubuntu computer this time. If you're using Windows, if you're using Mac OS, if you're using Linux, you know, they're all going to be a little bit different, okay? So I'm sure many of you are using Windows. I'm sure some of you are using a Mac. So obviously, you know, the fonts are going to be slightly different, but you get the idea. Okay, so let's just do bold, regular bold. That should be okay. Maybe just a little, you know, I mean, let's make that a teeny bit larger. Let's make that a 22. And what about, well, you know what, I like the other one better, so let's, sorry about that. Let's go back to Ubuntu Mono. Okay, there we go. We'll do the same thing here. Font, we'll do 22. I'm just going to type in 22. And Ubuntu Mono, and then bold. That looks terrific. And then we'll do the same thing with text. Let's see, font. And we can say 22. And we can, oh well, let me see, hold on one moment, let me, here we go, Ubuntu Mono. And you know what, I would like it to be bold. There we go. And yeah, you know what? I think that's going to be good enough. We could change the color. We could do all kinds of things. So text color. Oh, I don't know. Let's make that dark blue. And this could be text color. This could be. What color should we choose? How about, let me see, maybe a dark red, a nice dark red that's very pretty. We can make it even darker. I mean, we can change this in so many different ways. So text color, I'm going to choose the palette, and we could make that even darker, almost like a real. It's such a deep dark red that it looks almost black. You can do all kinds of things with it. So that looks good. And I think that's good. Okay. Okay, sensational. So let's take a look at the problem. Let me see here. So I'm going to read this problem. The table contains the state population and the number of licensed drivers in the state, both in millions for the states with population under 1 million in 2014. The regression model for this data is y is equal to 0.73 times x plus 0.02, where x is the state population in millions and y is the number of licensed drivers, also in millions, in the states. Okay, so let me just let me erase that. Hold on one second. Okay, how do I, wait a minute. Wait a minute. Okay, how do I do that? Wait a minute. Wait a minute. Erase alt suit. Wait a minute. There we go. Okay. Let me erase. Okay, hold on just one second. There we go. Okay. Okay, I'm still getting used to these various software tools. Sorry about that. So what we're going to do is population is equal to 0.74, 0.91, 0.96. So I'm looking at these numbers over here. I'm looking at these numbers right here. Okay, those are the numbers I'm looking at. Now let me just erase, hold on one second. Let me, there we go. So 0.74, 0.91, 0.96, 0.73, 0.85, 0.62, and 0.56. Okay. And that represents the x values. Okay, so these are my x values. These are the y values. All right, these are the x values. These are the y values. All right. Why did that line suddenly become so skinny? No, that's okay. I'll worry about it another time. Hold on one second. Okay, 1 second, guys. So, okay, that's really, okay. So one more time, guys. Let me do that one more time. So these are the x values. These are the y values right over here. Okay. So population represents the x values. Licensed drivers at 0.55, 0.69, 0.72, 0.55. Let's see, 0.55, 0.69, 0.72, 0.55, 0.63, 0.47, and 0.43. I believe that's it. Okay, so shift enter. So now I need to turn these into paired values. So my points are going to be table. Well, first of all, how long are these lists? Length, population, 7, length, licensed drivers, 7. So they should be same. They should be the same. They should be equal. I should have 7 numbers or 7 values in each list, the population list and the licensed drivers list. Okay, so points table population, make up a letter that you like. I'm using K. Licensed drivers, K. K goes from 1 to 7. So now I have my paired values. Okay, so now the next step is to create my scatter plot. So list plot points joined false. Let's see, plot markers. So for this, guys, use the forward, actually, no, it's the backward slash key. I like filled circles, filled circle, close it. So one more time, the backward facing slash key or backslash key, filled circle, and then close the bracket. Okay, and I'd like it to be 20 pixels across. Plot style, we're gonna say black, and let's see what this looks like. Okay, that's not too bad. So this picture needs a little bit of work. This picture could use a little bit of work. For one thing, okay, so if we look at their pictures, we can see that along the horizontal axis, we're going from 0 to 1.4. And along the vertical axis, we're going from 0 to 1. So what I'm going to do is this. We're going to do ticks. Along the x-axis, which comes first, we have 0, 0.7, 1.4. And along the x-axis, we have 0, 0.5, and 1. That definitely looks a lot nicer. Let's make this picture bigger. Image size is going to be, let's say, 500 pixels across. That looks much better. And you know what? I'm not getting my, okay, there's something a little weird here. So I don't like that. I'm not seeing the numbers here. I'm not seeing 1.4 on my x-axis, and I'm not seeing 1 on the y-axis. So what I'm going to do is plot range. X goes from 0 to, let's say, 1.5. Y goes from 0 to, let's say, let's go a little bit beyond the maximum, so 1.2. We could make this more like 1. Okay. That looks much nicer. Let's make those numbers a little bit bigger. Tick style, directive, font size is 24, font color is black, font weight is bold. Maybe that's just a little too big. How about 20? Maybe 18. Okay, that looks very nice. So it's starting to look a lot like their picture. You can see, actually you can see it's going to be this picture over here. So if we want to get the grid lines, what we can do is this. We can add grid lines. We can do grid lines. For the x-axis, how about we go in steps of, let me see. How about we go in steps of 0.1? So we could do table k. K goes from 0 to 1.4 in steps of 0.1. And for the y-axis, let's do something similar. Table k. K goes from 0 to 1 in steps of 0.1. Oops, sorry about that. And let's see what the picture looks like. Okay, that's pretty. We could do 0.05, 0.05. Let's see what that picture looks like. That's even nicer. Actually, let's go up to, okay. We could do 1.5 maybe. Okay, that's a very pretty picture. And then finally, for the actual regression line, if you actually want to draw that, so we would have to write comma and then plot. And then what is the, okay, so we're not we don't need to use y. We're just going to type 0.73x. You could write times x or space x, up to you, plus 0.02, 0.02, and x is going to go from, well, if you look at their graphs, they're going from 0 to 1.4, so x goes from 0 to 1.4. And plot style, we could make it a nice thick line and black. Now you're combining two pictures, so you need to use the show command. Show encloses the entire thing. Shift enter. And actually we could make that, let's make that 1.5. That looks a little prettier. Okay, so this is a very nice graph, and this is the correct answer to the problem. So it looks like it's definitely not going to be choice A, it won't be choice B, it won't be choice D. D is definitely wrong. It looks like our picture is the same as, it's the same as choice C. And yes, indeed, that is the correct answer, okay? Let's do part B. If the population of state H in 2014 was about 1.4 million, okay, use the model to estimate the number of licensed drivers in state H in 2014. So remember, we're not going to actually type 1.4 million, we're going to type 1.4. So that's going to be 0.73 times x. Remember, the space means times, plus 0.02, where x is replaced with 1.4. So the answer is okay, round to the nearest thousandth is needed. The estimated number of licensed drivers in the state H in 2014 is, okay, so this number has to be multiplied by 1,000,000. 1042, and then if we multiply that by 1,000,000, right, we add 3 zeros. That should be correct. Fantastic. Okay, and Pearson agrees with us. Part C, if the number of licensed drivers in state J in 2014 was about 1.043 million, use the model to estimate the population of state J in 2014. So here what we can do is we're going to use this, the solve command. So here for C, we have to estimate the population, which is represented as the x value. Okay, so we know that the number of licensed drivers was 1.043. 1.043. 1.043 is equal to, notice the double equal sign, 0.73 times x plus 0.02. What is x? Shift enter. So x is about 1.401. The estimated population of state J in 2014 is, round to the nearest 1,000, type a whole number. One second. The estimated population of state J is, so this one's a little bit tricky because here, okay, so for this one, let me type in a value here. X is equal to x as it's defined on the previous line. The percent means the previous line. Okay, x is equal to x as it's defined on the previous line. So here, this represents millions, so I have to, so I have to take x and multiply it by 1,000,000. Okay, so that, yeah. So here we're going to do, well, if we round this out to the nearest 1,000, see this is, okay, so this is a little bit, this one's going to be a little bit tricky because here we have, oops, wait, that was not good. Okay, shift enter. Let me just erase this. So here we're going to have 1,401,369. 1,401,369. So if you round that out to the nearest 1,000, that's going to be 1,401,000. So that's going to be 1,401,000. And that should be correct. And it's correct. Okay. Let's do the next problem just for reinforcement, okay? Let's do the next one. Just give me a moment here, guys. I'm going to take a very quick drink. Okay. A linear regression model. So I'm reading problem number 78. A linear regression model for the revenue data for a company is R is equal to 26.8T plus 204, where R is total annual revenue and T is time since January 31st, 2002 in years. Okay, 1 second. 12 months ending January 31st, 2002. So R is the total annual revenue. Let's see, hold on 1 second. For a company, is R is equal to 26.8T plus 204, or R is total annual revenue, and T is time since January 31st, 2002. So at the end of January 31st, 2002, the revenue was 202. I'm assuming that's $202 million. For January, at the end of January 31st, 2003, okay, $234 million. So a lot of that money goes back into the company, but the gross profits is at the bottom. Okay, so draw a scatter plot of the data and a graph of the model on the same axes. So here, they're a little, they're not, hold on one second, let me make this a little bit larger. Yeah, they're not telling us which values are plotted along the x-axis and which values are plotted along the y-axis. I'm pretty sure, guys, that, you know, in the table, the first value, which is revenue, that's going to be plotted along the x-axis, and gross profit is going to be plotted along the y-axis. All right, that's pretty standard, so let's go with that assumption, and it should be okay. All right, so let's start this over again. I'm going to clear, let's see, clear global, oops, that's not quite correct, global, okay. So why am I doing this? Why am I entering this command? This is the backtick, by the way. All right, this is the backtick. Why am I entering this command? If I enter, and of course, as usual, shift enter. If I enter this command, guys, all the previous stuff is now undefined. So x is no longer 1.401369 whatever. X is now simply a symbol. Okay, so here x was not a symbol, x was a number. Here x is a symbol. Okay, so now we're starting over again with a brand new problem. So we have revenue. Revenue is equal to, here, let me move this over just a little bit. Let's see. Oh, I see, this is billions of dollars. So this is, right, I'm sorry, not millions. I said millions. This is billions of dollars. So $202 billion, $234 billion, $258 billion, et cetera, et cetera. Right, I said million. That was a mistake. Okay, so this is going to be 202, 234, 258, 282, 312, and then this is going to be, okay, that's it. Okay, and then we have gross profit on the bottom, gross profit, and that's going to be 42, 53, 59, 64, 71. Okay, and both lists should have an equal length. They should both contain five values. And gross profit should also contain 5 values. Points. Points was defined above. It's no longer defined because I cleared it. Table. Let's see. We have... one second. So we have revenue. I'll make up another, I like the letter I, we can use the letter I, and revenue I, and gross profit, here, I'm going to expand this a little bit, gross profit I. I goes from 1 to 5 because I have 5 points. I have 5 points. So these are my paired values. Let's see what the picture looks like. List plot points. Well, we can certainly do a little better than that, right? So joined true would look like that. That's not what we want. That's definitely not what we want. Okay, joined false. I think joined false is the default, but just in case, you should You should enter it anyway. Plot markers. Okay. Filled circle. And 20 pixels across. Plot style is, let's say, blue. Okay, that's starting to look nice. It looks pretty close to what they have. Strangely enough, why do they have... Okay, so I'm looking at the numbers they have on their X and Y axes. It doesn't really make a whole lot of sense to me. That's very, very strange. It does not... Hold on one second. I want to see something here because that's very strange. Hold on one second. Show plot, and their equation is 26.8 times t plus 204, where t goes from... Now this is the confusing part, because their x-axis, I mean, this is very, very strange to me. Along their x-axis, they're going from 0 to 10, which really... Oh, now I see what they're doing. Time since January 31st, 2002 in years. Okay, so we made a mistake here. So if you look at their x-axis, now what is very confusing... R is total annual revenue and T is time. Okay, now I see what's going on. Now I see exactly what's going on. So we made a little bit of a mistake here. All right, if you look at their picture at the bottom, if you look at, okay, now I see what's happening. Time since January 31st, 2002. So this is going to be 0. This is going to be 1, 2, 3, and 4. So actually, okay, we need to start this problem over again because this is a little bit, this is incorrect. Okay, this is a little bit incorrect. So what we have here, okay, for this picture, for the first picture, guys, they actually want the time since January 31st, 2002. So this is going to be time 0. This is going to be time 1, 2, 3, 4. This is 0. This is 2003. It's 1 year later. 2004 is 2 years later. 2005 is 3 years later. 2006 is 4 years later. So what we need to do is time is equal to range 0, 4. Okay. And let's change this. Table... hold on one second. And are they... See, this is a little bit weird because they're doing... R is total annual revenue. Okay, so what they're doing here, they're doing time I, revenue I goes from 1 to 5. All right, that makes a little bit more sense. So list plot points joined false, plot markers filled circle, close your brackets. Let's say 20 pixels. Plot style is blue. Okay, that makes a lot more sense based on what they're showing. Okay, their x-axis goes all the way from 0 to 10. So we're going to do plot range goes from, we'll just do range, well, no, I don't want to do that. Okay, sorry, 0 to 10. And then the y-axis goes from 0 to 500. 0 to 500. Oops, forgot to, okay, sorry about that. We have to, there we go, that looks a lot better. All right. We're going to have to go, because we have a circle that's been cut off here, so let's go, how about from -1 to 10. There we go. So now the circle is not cut off, and we could, you know, we could extend the vertical axis down a little bit. We could go negative, I don't know, 25 or something, or just to make it look a little nicer. You know, something like that. That's good enough. We could go, I don't know, we could, you know, I'm just trying to make it look a little prettier. So, okay, so the picture is starting to look a lot better. And we could do image size, let's, whoops, sorry, image size, 500 pixels, make it nice and big. Okay, and it looks like if you look at my picture and if you look at their picture, you know, the scaling is a little bit different. The scaling looks a little bit different. So to scale things, let me see what happens if I do this. I don't think this is going to look too good. Well, no, not too bad. That's not too bad. Let me shorten my vertical axis a little bit. So I'm going to make that 0.8. Okay. And maybe -50. Okay, good enough. Excuse me. And now I want to, so aspect ratio just tells you how long is the vertical axis compared to the horizontal axis. Again, this is it's a matter of artistic license. You decide, experiment with it. You decide, you know, what you know, how pretty or not pretty you want your pictures to be. All right, so then we can, you know, so here, if you look at their picture, they have 0 and 10 and 0 and 500. Oops, okay, hold on one second. So we could do ticks 0, 10, and 0, 500, and that's it. And then, yeah, 0's not showing up, which is a little frustrating, but, yeah, that's okay. That's fine. So, and then for tick style, we could say font size is 24. Okay, so you can see it's frustrating that the 0 is not showing up, but yeah, that's a little bit frustrating. So that, don't worry about it. It's not a big deal. And that's a little big, so we could say 20, and you know, we could say font color is, I don't know, black. Okay, that looks fine. And then if you look at the grid lines, we could just do count from, well, for grid lines, so 0 to 10 along the x-axis, and then for the y-axis we could do 0 to 500 in steps of oh, I don't know, 25. Let's see what that looks like. Okay. That looks okay. Maybe the x-axis, let's make that -1, and we could make this -50. Okay, that looks, pretty nice, I suppose. And then finally, for your final touch, to make this picture look just like what they have, we would have to put in the actual function. So show plot 26.8 times t plus 204. T goes from 0 to 10. And your plot style would be thick and blue. Okay, and so we can see which picture is it? It looks to me like it has to be this picture. Actually, we could make this to make this picture look a little nicer. We could make the lower limit -1, so Shift Enter. But you get the general idea. So it looks to me like the correct answer should be D. It should be D. And Pearson agrees with us. The answer is D. All right, continue. Predict the company's annual revenue for the period ending January 31st, 2010. Well, that's 8 years after 2002. So then what I would do is 26.8 times t plus 204, where t is 8. Or t is 2010 minus 2002, which we know is 8. So that's going to be, round to the nearest $1 billion is needed, $418 billion. That's it. Okay? Now I realize, guys, that some of the Mathematica stuff is very new to you. You just have to practice with it. You really just have to practice with it. So if you're not sure how to do something in Mathematica, my dog is so cute, he's resting on the couch. Okay, hold on one second. If you're not sure how to do something, type in the double question mark list plot. Okay, and then, look at the examples, details and options, examples, read through the examples. Read through the examples, okay? So let's say, there's something in Mathematica that I don't remember how to do, ticks. Okay? Ticks is an option for graphics functions that specifies tick marks for axes. So, let's see. So read through the examples, read through the documentation and then just do some experimentation on your own. And I realize this looks complicated. It's really not that big a deal. I don't think Mathematica is that much harder than, let's say, Microsoft Excel. Microsoft Excel, people think it's easy. Actually, Microsoft Excel is not that easy. It gets pretty complicated. So I don't think Mathematica is really that much more difficult than a program like Microsoft Excel. Because Microsoft Excel does get really pretty tricky pretty fast. You can do a lot of stuff with Excel, but it does get very complicated. So really, guys, to me, you may think, oh, this program is so difficult, but most of you are business majors. Most of the students who take finite math are majoring in some type of business, international business, marketing, finance, accounting, business management. And you guys need to become comfortable with some of the basics. You need to learn some business mathematics, But you also need to learn some of the computer applications in the business world. And, everyone thinks, well, all business people are into Excel and that's as far as it goes. But that's really not true. I used to know a payroll manager who had to be very good. She had to know a lot of SQL. It's called SQL. Okay, where's my cursor? I just put my cursor someplace weird. All right, one second. She had to know something called SQL. SQL. Some people call it SQL, and some people call it SQL. It's a database management system. And some payroll managers have to be very good at it. Well, in a lot of ways, it's very similar to Mathematica. Okay, not all payroll managers use Excel. A lot of them rely on something called SQL or SQL, and SQL is actually considered to be much faster and more efficient than Excel. And SQL has a lot in common with Mathematica. So, it's a mistake. A lot of business students think, well, all I need to learn is Excel. That's a mistake, okay? You need to become comfortable with computer software in general because it's all over the place nowadays, especially in the world of business. And business is everywhere. Everything these days is a business. I don't know if that's good or bad, but it doesn't really matter. It just is what it is. It just is what it is. Everything nowadays is a business. And businesses rely very heavily on computer technology. And computer technology relies very heavily on mathematics. So it's all kind of interconnected. Okay, guys, I think that's going to be it for today. Hopefully this wasn't too horrible for you, And also, don't forget, okay, what happened to... All right, wait a second. Here, hold on. Please don't forget, when you're doing these problems, when you're doing a lot of these problems, you need to take advantage of the resources that are available to you. For example, question help. Help me solve this. Well, if you click on help me solve this, it's not going to give you credit for the problem. You're going to have to do, you'll have to do a different problem in order to get credit for the problem. View an example video. Okay, let's see. What's the video like? Let's see. What is the video like? Okay.
In this last example, we're going to look at a linear regression model, and we're going to use it to answer some questions.
Okay, so you can look at the video, you can open up your textbook, view an example, help me solve this. I mean, there's a lot of things you can do, okay? Take advantage of the resources that are available to you. That's really important. All right, I think we're done. Have a great night, guys, or a great day, and good luck with your homework. Please finish it up as quickly as you can. Next week, I will assign the Chapter 2 homework. You will have 2 weeks to work on that. And guys, remember, I am going in for surgery soon, so I'm going in for surgery January 27th, and even before January 27th, I have a lot to do to prepare for surgery, so please, for 2 weeks after my operation, I'm really not going to have much time for you guys. So my chairman already knows. I told her a couple months ago, so it's or maybe a month ago, so this is no surprise to the chairman of the math department. So for the Chapter 2 assignment, you guys are going to have to work very independently. However, when we start Chapter 3, I should be feeling much better, and I will definitely make a couple of tutorial videos to help you with Chapter 3. Chapter 3 is actually pretty tough. Chapter 3 gets into a lot of, pretty complicated stuff. Chapter 2 shouldn't be too bad. You should be able to do that by yourselves. I think for Chapter 3, you're going to need much more of my assistance, okay? All right, guys, I think that's going to be it for today. I think we covered a lot of material, and I think that's enough, okay? Take care and be well. Stay safe and be healthy, and stay healthy and be well, okay? Bye-bye.